This is the di-soric AutoVision software. We'll start up here at the File menu, just your standard File menu. The next menu over is your Help section. Now, I encourage you to take a look at the Help section here. It is full of some fantastic resources. You can look up every feature that's in this software and learn how to use it, and it's easily searchable. First thing we're going to do is we're going to select the device. With the AutoVision software, you have the option of connecting to an emulator. This would be, if you don't have a camera to play around with, you can download the software and just play around with the tools. Just quickly create a new job here. And this is just a static image that you can use to learn how to use the software. Today we're going to actually connect to the camera. Now, when I connect to the camera, I can look at the details here. Now, when the camera comes out of the box, there is an IP address printed on the label. This is actually what the IP address is for my camera. When you're hooking the camera up to test it, you can just set your network range on your laptop computer to be within the first 3 octets of 192.168.0, and then just set your computer to a different address than this. Make sure your subnet mask is within range, and you should be able to very easily connect to the camera. Now, if you click on this little lock icon, you can actually open this up, and you can modify these settings. I can change my IP address. I can enable DHCP, I can change my Ethernet interface, and I can also change my RS-232 settings. Okay, so what we're going to do here is we're going to create a new job. Okay, this job that I'm going to run here is just looking at some simple washers, so some very simple objects. First thing we need to do is focus the camera, set up my image. So we have a couple of options here. I can acquire a single image, I can put it into a live run mode, or I can wait for a trigger. So in my case, I've actually got a sensor connected and I'm going to trigger my images. But for alignment here, I'm going to turn the trigger off and I'm just going to put the camera into free run mode. I'm just going to center the objects in the middle of the field of view. Turn that off. Over here on this side, I have my auto calibration or my calibration features. The calibration or auto calibration is the one that I typically use most of the time. Again, this is an autofocus camera. So there we go. We don't have any strange glare. I'd say that image quality is pretty good. You can actually also do a quick focus if you like, although I don't know why you would do that. The autofocus works very, very well. I can focus in on a specific area or detail if I like. And I can also here, with this enable zoom mode, I'm switching between the 2 focal lengths in the camera. I'm just going to do an auto calibrate. I want to take a look at both of these washers, and that's fine. So we're going to go from here. If you want, you can play around with your exposure, your gain, and your focus. You can also change the lighting effect. So you can either turn the light on, off, you can strobe, do a power strobe, and you can use an external strobe from a flash controller. Now the lighting select here, so you do have internal LED, those are the integrated lights, the white and red, and your expansion module. So that's the light that you order the camera with, whether it be high intensity white, high intensity red, or high intensity ultraviolet. You can also choose to buy an expansion module and even put blue in there if you like. Okay, so we've acquired our image. I'm going to move over to the next tab here, which is the edit section. So this is where I'm actually going to load the tools that I need to be able to do the job that I need to do. On the left-hand side here, you can see this is my tool tray, and these are my tools. So I can either drag and drop the tools in there or just simply click on them to put them in the tool tray. They will be listed in order of operation. So on this side here, I can see by exposure and gain and focus. I'm using a sensor to trigger, so I'm going to set my trigger to sensor. It is sensor 1. The particular sensor that I am using is going to trigger on a high to low transition. I don't need to use a trigger delay, so we're good here. Okay, the first tool that I want to put in place is I want to locate the object that I'm interested in inspecting. Okay, so here I have my location tool. What I'm going to do is I'm going to set my region of interest. That will be the outer box here. I'm going to set it somewhat like this. So basically, anytime this object comes within this outer rectangle, it should put the tool in a positive state. Just click this little button here to train the tool. Now it's going to be looking for this object anywhere within this region of interest. I'm going to change the fit quality on this to just normal. I don't need it to be precise. All the washers are pretty much the same size, as you'll see. Okay, so I'm going to rename this. I'm going to call it locate washer 1. Perfect. Okay, I'm going to now measure the ID, or inside diameter, of the washer. And I'm going to do that with my measurement tool. So with this tool, I can select a couple of different measuring methods. So width, height, circle, point to point, point to line, and angle measurement. In this case, I'm going to use the circle measurement. I'm going to bring my template over top of washer 1. I'm going to bring in the inside diameter, well, the circle start, we call it. I'll bring in the circle end in this case. Now I am measuring from the inside out. The number of vectors is preset at 30. My polarity is light to dark, which is fine. I'm going to change the edge sharpness to sharp. And you can see that kind of tightened up the points here. Okay, we'll leave that there. I'm going to rename this to circle 1 ID. Now you can see here automatically this is the locator. So what this means is this tool, this measurement tool, is going to auto locate to this X and Y coordinate. So these two tools are now linked. I can turn that off if I like, but by default it is enabled. And I want that because this part could actually be presented anywhere within this region of interest, and having this enabled just means that this tool is going to follow this tool. So now I want to do an outside diameter measurement. So I'm going to add another measurement tool. I'm going to change it to circle measurement. I will drag the template over top of the washer. I'm going to bring this in pretty far. Maybe I'll center it a little bit more. There we go. Set it out there. Now I want to change the scan direction. I want to go outside in. And there we go. Now I'm measuring the outside diameter. Again, I'm going to change this to sharp edges. Okay. So that looks good. I'm going to go back to the circle 1 here first because there's something that I forgot to do. And I'm looking at my radius here, my inside diameter, and it's 21.51 pixels. I want to set my tolerance here. So I'm going to actually set this to, let's try 19 for the minimum and maybe 25 for the maximum. So now as long as this measurement falls within this tolerance, the tool's condition will be positive. I'm going to do the same for the outside diameter here. I'm measuring 49.85. So, I'll set my lower tolerance to 47 and my upper tolerance, we'll say 52. We'll see how well that works. Okay, I'm going to change the name of this to circle 1 OD, and again I want to make sure that I link this to the locate washer tool. Excellent. Now I actually want to count these washers as part of my process. So I'm going to put a count object in here. I'm going to turn off the locator because I don't necessarily need to follow the washers. I just need to set a specific space here, or range for my region of interest. Now I'm going to count any washers that fall in or come into this particular region of interest. Here I have my tolerance. I should always have 2 washers, so I'm going to set my min to 2 and my max to 2. Perfect. Okay, so now I want to focus on washer number 2. So the next thing that I'm going to do is I'm going to add a locate. I'm going to turn my location pin off because I don't want this tool to follow the first location tool. And I'm going to do basically the exact same thing I did for washer 1. I'm going to train the tool. I'm going to set my fit quality to normal. Perfect. Okay, the next thing I'm going to do is I'm going to put a measurement tool in for the inside diameter of washer 2. Oh, we might as well rename this while we're here. Call it locate washer 2. While we're here, we might as well do circle 2 ID. Change this to a circle measure. Exact same process. Do the sharp edges. I'm going to look at my measurement. It's telling me 21.53. It really should be the same, so I'm going to set it to the same as circle 1, which is 19 and 25. Excellent. And again, this circle is going to be linked to the location of washer number 2. We'll do the same thing again for the OD. I will rename this This didn't take for some reason. There we go. Change this to sharp edges. We'll look at our measurement at 21.47. I need to change that to outside in. Okay, great. I should have the same measurements, 49.01, so I'm going to set it to the exact same thing of 48 and 52 for my tolerance. I'm going to save this job to disk. I'll just call this washer 2. Great. Now what I can do here is I can run through a sample. I can either just try the job once, I can run the job in a loop, which is in a free run mode, or actually run a test. The first thing we're going to do, just to make sure everything is working fine, is I'm going to just try the job in free run or loop mode. So that's my first trigger, and this is the master, essentially the good sample. You can see that it's passed all of the tests. So it's located washer 1, ID is within range, OD is within range. There are 2 there. Again, ID and OD for the second washer is fine too. The next sample. Okay, so we have 3 washers in here. So it's found washers. The ID is okay. The OD is still within range. However, it is counting 3 blobs or 3 washers. So there's definitely an issue there, and the inspection has failed. Move on to the next one. Okay, now, may be hard to see in this image here, but I do have 2 objects. The ID and OD for number 1 is fine. The OD for number 2 is fine, but the ID is incorrect, and that's because it's out of tolerance. So ID is only at 16.7, and that is correct. This is a smaller ID washer. And then the final sample. Okay, so it's working as well. We have location of washer number 1. The ID and OD is correct. It is counting 2 washers, because that's correct. It has located the second washer. However, the ID and OD are both out of tolerance, which is correct. So our test is working fine. Okay, so now what do I do with all of this information? Well, I can link all of these tools individually to my PLC via these little link icons. So for example, here for the locate washer, my fit quality, I can send that information to my PLC via Profinet or Ethernet IP. I'm using a float here in this case. And every one of the tools also has these links for different features, the fit point, the radius, the number of parts, so on and so forth. So I can link each individual tool to the PLC that way. Or I can use the digital outputs. So if I click here, I can change my digital outputs or assign them to specific functions. So let's set digital output number 1. So currently it's not connected. What I can do is I can connect it to any one of these functions. So in this case, what I'm going to do is I'm going to set output number 1 to inspection passed. What that basically means is as long as all of these tools are in the positive state, this inspection pass will be a green check mark and it will output on number 1. I can set it to latch. In this case, I'm just going to pulse it. Let's do number 2. So number 2, I'm going to set as an inspection fail. We'll keep that latched. And then I'm going to set my output number 3 to inspection done. So now I know, has the camera performed the inspection, and then did it pass or did it fail? The last thing we're going to do is put the camera into full run mode. You can see I have my inspection window here, my inspection status here, and the individual tool statuses here. Let's run one trigger through and see what happens. So this is the master sample, the only good sample of the 4. And you can see I've got 1 inspected, 1 passed, 0 failed, and these are the individual tool statuses. The next thing I'm going to do is reset the count, and I'm going to run the job through its entirety, so 4 triggers, just to see what it's going to look like. Here we go. Perfect. So here I've got 4 inspected, 1 pass, and 3 failed.